Here we have an iterative formula question where first of all we need to establish the fact that there is a solution between x equals 1 and x equals 2 for this cubic. So we need to replace the letter x with a 1. So we get 1 cubed plus 7 lots of 1 take 10, which comes out as 1 plus 7 take 10, so that's minus 2. Then we have to do the same with 2, so we get 2 cubed plus 7 2's take 10 equals. Now this can be obtained by using the Casio calculator and by first of all putting 2 and pressing equals. What this does is it stores 2 into the answer button. If I then type in the equation using the answer button, answer cubed for x cubed plus 7 answer for 7x take 10, then the calculator gives us the answer straight away, which in this case is 12. That therefore determines the fact that there is a solution between x equals 1 and x equals 2. The reason is there's a change of sign. So change of sign implies solution between x equals 1 and x equals 2. The reason is because on the x-axis, at 1, at 2, at 1 we're down at minus 2, at 2 we're up at 12, so the curve must have crossed the x-axis somewhere between 1 and 2. So that's why I'm able to write that statement. Now, using this iterative formula, starting with x0 being 1.5, we're able to establish x1, x2, x3 and x4, again using the calculator. What we need to do to work out x1, we need to type in 10 divided by xn squared, means your last value, which is 1.5 squared, plus 7. Now I only write that out once because I let the calculator do all the work. Again, if I was to type in 1.5 and press equals, that stores 1.5 in the answer button. I can then type this into the calculator using all the buttons available. Fraction button first, 10 for the 10, arrow down. Now I don't need to type that in, I can just type answer squared for x squared, knowing that 1.5 is already stored in that answer button. Plus 7, so plus 7. Now it might seem a faff doing that, but this is where it is excellent. Press equals, and that gives us our first calculated value of 1.081, and it carries on. To establish x2, all I have to do now is press equals again. For the simple reason I already have this displayed, and that answer is now that number. So press equals, there's my second calculated response. And it carries on. For x3, just have to press equals again. So going to that trouble with that first one saves all the trouble thereafter. So there we get 1.1766, and it carries on. And if I press it again, I'll get x4 as we've been asked for, which is 1.1926, etc. Now they're the only ones we've been asked to work out. Hence, in part C, what can you deduce from the findings? Well, we can see that, yes, they've still got an answer between 1 and 2, but we can see that the solutions are getting closer and closer to x equal to 1.2. If I carried on further and it worked out x5, x6, x7, I'd get it more accurate than that. But from the findings there, I can say that the solution to 1 decimal place is most likely to be 1.2.